we know that n is the period number. Okay. We also know that n is related to the energy. So now in a 1 electron hydrogen atom, which is the simplest case we have, we say that as the energy increase, you have your ground state, and the ground state would be 1s. And you can have 2 electrons in this, so one going up, so a positive half and a negative half. And then you have your second energy, where n is equal to 2. Okay? And n equals 3, and blah, 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 blah. Now, if the subshells are on the same energy level, we call that degenerate levels. Now notice that the subshells, these little boxes, have all the same energy. So all the subshells are degenerate. And in the case of the hydrogen, or if you have 1 electron, everything in a period is degenerate. And so what you'll see is that here you would have 1s. If you have 2 electrons, it would be 1s1. And we start and fill up as you increase. So if you increase the number of electrons, you can only fit 2 here. If you have 3 electrons, it would go up here. Now, as I mentioned that the energies of when you add more electrons, the levels become not degenerate. And so what you see is there's a splitting. And so for anything above 2 electrons, so helium and above, you see that the s and the p's have different energy. And so you start with the lowest energy, because that's more favorable, and you start plugging in electrons. So if you have 2 electrons, it'd be 1, 2, then 3. And you always start, and we'll learn why in a moment, or Wednesday, I guess. You always start with a up arrow and then a down arrow. So you would have 1s1, 1s2, 2s2, 2s1, 2s2, then you go up to 2p, then 3s, 3p. Notice that the energy separation between 3p and 3d is very great. However, the 4s has actually a lower energy than the 3d, which means that the electrons going from 3p would actually fill up in 4s before it does in 3d. So what does that mean for us? So if we look at the periodic table, okay, what you'll see is you can predict the electron configurations of these elements by looking at the periodic table. So let's see if I could do that here. Sometimes I actually have a button to write in, and I don't. So let's see. Okay. Let's fill this in and pause this. Okay, so the electron configuration for, say, boron, which is B, there are 5 electrons in it. So if we look here, you see that the lowest energy would be n equals 1, so that would be the first period, and there's 5 electrons in the ground state boron. Because remember, the neutral elements have the same number of protons as electrons. So we know that there are 5 electrons. Now, the the first one that goes through, why there's a, get rid of that, is what we say is 1s, and both electrons are filled up, so 1, 2, and so we represent that with a superscript 2. The next level is, so this is n equals 1, this is n equals 2, so we have 2, and both s's are filled up, so 2s, 2, and then we jump to the p orbital, and this is in the first position, so this would be 2p1. Okay, and that's all for boron. If we have something, let's say copper, we could write out 1s2, 2s2, 2p6, 3d2, 3p6, and so forth. Or we know a shorthand where these noble gases are completely full. So if you look at neon, let's do neon first actually. That would probably make a little bit more sense. Neon has 1s, 2, 1s, 2, and then 2s, 2, and then 2p, 1, 2, 3, 4, 5, 6. So 2p6. That needs to be a subscript or a superscript. That means that everything is full. Okay, so all the subshells are full and happy. So if we go on and say that if you look at sodium, what that means is it's just like neon, but with 1s, or 1 extra electron in the 1s1 spot. So sodium would have it, so it would be just like neon, but you have a 1s1 filled also. So this is called the noble gas configuration. So instead of writing all of this for elements down here, we can make our lives a little bit simpler by looking at what the noble gas is before your element. So if you have copper, the noble gas before that is argon. So copper would be written argon in brackets, and after argon, right? So this is 1, 2, 3, 4s. So 4s, and both of those are filled. And then remember, this is the d orbital, and those are n minus 1. So if this is the fourth level here, then this would start out as 3. So it would be 3d, and it would be 1, 2, 3, 4, 5, 6, 7, 8, 9 as the electron configuration. Now there's two ways to write this. What I think is the easiest to do is go by increasing numbers. Okay? So the end shell tells us where the last electrons are. So another way of writing this, and I think would be more appropriate, is 3d, 9, 4s, 2. And that goes by increasing number of n. And we'll learn how ions are different than ground state electrons in future lectures, so probably Wednesday. So I want you to practice electron configurations. If you go to the As You Learn site, there's a worksheet you can work on. It's not for grade, that's just for you to practice. If you have any questions, please let me know. The clear question on Wednesday will be about electron configurations. So practice that. And again, if you have any questions, please add them to the discussion and I will answer them as they come up. Have a great day, and I hope that I have my voice on Wednesday.